Hey everyone, Adam Infinity here, and welcome back to Singularity Today. Today we are going to dive into the latest groundbreaking research in artificial intelligence and its impact on science, technology, and even our everyday lives. Get ready to be amazed by advancements in 3D modeling, language models, and even facial recognition. We'll explore how these new innovations are revolutionizing the way we understand and interact with the world around us. So grab a seat, get comfortable, and let's journey into the future of AI together. In the research titled Con 2.0, Kolmogorov-Arnold Networks Meet Science, the researchers are trying to bridge the gap between artificial intelligence and science by proposing a framework that combines Kolmogorov-Arnold networks, cons, with scientific principles. The framework uses cons for three important tasks in scientific discovery: finding key features, identifying modular structures, and uncovering symbolic formulas. This collaboration works both ways. Scientific knowledge is incorporated into cons, and scientific insights are extracted from them. The research highlights new tools in the API-CANS package, like Multcon for cons with multiplication nodes, compiler to translate symbolic formulas into cons, and a tree converter that changes neural networks into tree graphs. The researchers demonstrate the ability of cons to discover diverse types of physical laws, including those related to conserved quantities, Lagrangians, symmetries, and constitutive laws. This research could have a significant impact on various scientific fields by providing a powerful tool for uncovering new patterns and generating hypotheses. Imagine using this framework to analyze data in fields like physics, chemistry, biology, or even social sciences. This could lead to breakthroughs in understanding complex phenomena and developing new theories. In the research titled Demystifying the Communication Characteristics for Distributed Transformer Models, the authors investigate how communication patterns in distributed training of transformer models affect their performance. They focus on based language models as a prime example. The research reveals that optimizing small message point-to-point communication is crucial, and there are correlations between factors like sequence length, processing speed per GPU, model size, and optimization techniques employed. This research provides valuable insights for framework and high-performance computing middleware designers, guiding them in optimizing communication strategies for efficient training of transformer models. This research has the potential to significantly improve the speed and scalability of training large language models, vision transformers, and other powerful deep learning models, ultimately leading to faster development and deployment of cutting-edge AI applications. For instance, better communication strategies could enable faster training of language models, leading to the creation of more advanced chatbots and language translation systems. Similarly, faster training of vision transformers could facilitate the development of more accurate image recognition and object detection systems. In the research titled SpaRP, Fast 3D Object Reconstruction and Pose Estimation from Sparse Views, the authors tackle the challenge of reconstructing a 3D object from a few, possibly widely spaced images. This is like trying to assemble a 3D puzzle using only a handful of pieces. Existing methods often struggle with this task, either producing unrealistic results or requiring a lot of processing time. SpaRP, however, uses a clever approach, drawing inspiration from two image generation techniques. It trains a model to predict the position of the cameras that captured the images, along with a set of virtual images taken from different angles. These predictions are then used to generate a 3D model of the object and refine the camera positions. The researchers found that SpaRP significantly outperforms existing methods in terms of accuracy and speed. It can reconstruct a textured 3D model within a mere 20 seconds. The potential impact of this research is huge, as it could revolutionize how we create 3D models for various applications. Imagine, for example, using a few photos of a real-world object to instantly create a virtual replica that can be used in virtual reality, gaming, or even for medical simulations. In the research titled Transformers to SSMs, Distilling Quadratic Knowledge to Subquadratic Models, researchers tackle the challenge of improving the efficiency of transformer architectures while retaining their powerful language modeling capabilities. Transformers, known for their ability to capture long-range dependencies in text, are computationally expensive, particularly during inference. This research proposes a method for efficiently transferring knowledge from a pre-trained transformer model to a more computationally efficient architecture, specifically a state space model SSM. The key takeaway from the research is the successful development of a technique called Mohawk, which enables the distillation of a transformer architecture into an SM. The research demonstrates that Mohawk can leverage the computational investments already made in training large transformer models to enhance the performance of other architectures like SMs. This can pave the way for building more efficient and effective language models, potentially leading to advancements in various natural language processing tasks, such as text generation, translation, and question answering. Imagine being able to enjoy the benefits of a large, powerful language model without the hefty computational burden. This is precisely what this research strives to achieve. In the research titled Imbalance-Aware Culvert-Sewer Defect Segmentation using an enhanced feature pyramid network, the authors tackled the problem of identifying defects in sewer pipes and culverts using images. This is a real-world challenge because datasets used for training these models often have an imbalance. There are way more images with no defects than those with defects. This causes the model to become biased towards the more common class, no defects, making it less effective in detecting the actual defects. To address this, the researchers proposed a new model called EFN, which is a type of deep learning network. EFN uses a few tricks to learn better from the images, even with the imbalance. The results were pretty impressive. AFN performed better than other similar models on both culvert, sewer, and aerial images. It also showed significant improvements when techniques like class decomposition and data augmentation were used. The research has a potential to be very impactful as it provides a way to improve the accuracy of detecting defects in infrastructure like sewer pipes and culverts. This could be crucial for preventing costly repairs and ensuring public safety. For example, it could be used by engineers to automatically identify areas in need of repair, leading to more efficient maintenance and resource allocation. This could also be applied to other types of infrastructure like bridges, roads, or even buildings, helping us to maintain our infrastructure and prevent disasters. In the research titled NeuRodin, a two-stage framework for high-fidelity neural surface reconstruction, the authors address a common issue with surface reconstruction using signed distance functions, SDFs. These, while powerful, often struggle to capture detailed geometric structures, leading to imperfections in the reconstructed surface. The authors found that this problem arises from how SDFs are converted into density representations and how they handle geometric regularization. To overcome these challenges, they propose NeuRodin, a new two-stage neural surface reconstruction framework that achieves high-fidelity reconstruction while retaining the flexibility of density-based methods. NeuRodin utilizes innovative techniques to handle arbitrary shapes and reduce artifacts. Experiments on the tanks and temples and SCANIT datasets show that NeuRodin excels in reconstructing both indoor and outdoor scenes using only ArgB images. This research has the potential to significantly impact fields like virtual reality, augmented reality, and computer graphics by providing a more accurate and efficient way to reconstruct complex 3D surfaces from real-world data. Imagine being able to create realistic virtual environments or interactive 3D models using only photos. That's the kind of impact this research could have. In the research titled Fairness Undercover, Evaluating the Impact of Occlusions on Demographic Bias in Facial Recognition, the researchers investigated how things like hats, sunglasses, or even just shadows can affect how well facial recognition systems work, especially when it comes to different ethnic groups. They found that these occlusions actually make the problem of bias in facial recognition worse. The systems become less accurate and fairer when they have to deal with these things. The research also showed that the way the systems are affected by occlusions is not the same for everyone, with African individuals being particularly impacted. This means that facial recognition systems might be even more likely to misidentify people from certain ethnic backgrounds when they're wearing things that cover parts of their face. This research has important implications for the future of facial recognition technology. It shows that we need to be more careful about how we design these systems to make sure they are fair and accurate for everyone, even when there are occlusions. It also highlights the importance of considering the impact of occlusions on different demographic groups when evaluating the fairness of these systems. In the research titled SMILE, Zero-Shot Sparse Mixture of Low-Rank Experts Construction from Pre-Trained Foundation Models, researchers tackle the challenges of merging deep learning models. Deep learning models trained on massive datasets are expensive to train from scratch. Merging these models, called model fusion, allows us to leverage existing knowledge and create new models faster and more efficiently. However, model fusion can introduce conflicts between the parameters of different models, making it hard to interpret the final result. This research introduces a new method called SMILE, which tackles this challenge by cleverly adapting existing models into a new mixture of experts model without any additional training data. SMILE builds upon the observation that when fine-tuning a model for a new task, most of its important parts remain intact, while only a few less important areas are adjusted. By applying this insight, SMILE manages to address the problem of conflicting parameters and creates a more efficient and interpretable model fusion process. This research demonstrates the effectiveness of SMILE across various tasks like image classification and text generation, showcasing its ability to adapt to different types of models. The authors highlight its scalability and potential to improve model development for a wide range of applications, ultimately benefiting various fields that rely on deep learning models. In the research titled Customizing Language Models with Instance, Wise LoRa for Sequential Recommendation, the authors explore how to improve recommendation systems by leveraging the power of large language models, LLMs. Think of LLMs as super intelligent assistants that can understand and reason about complex information. The research focuses on recommending items to users based on their past interactions, like what they've bought or viewed. The challenge is that users have different preferences, and a one-size-fits-all approach doesn't work well. To address this, the researchers propose a new technique called instance-wise ILoRa. Imagine you have a team of experts, each specialized in different areas. ILoRa essentially creates a team of expert elms, each tailored to a specific user preference. This allows the system to provide personalized recommendations based on the individual user's behavior. The research shows that ILoRa outperforms existing methods, leading to more accurate and tailored recommendations. The impact of this research could be significant as it can be applied to various recommendation systems, such as those used in e-commerce, entertainment platforms, and personalized news feeds. Imagine a shopping website that suggests products specifically tailored to your browsing history and style preferences, or a movie streaming service that recommends movies based on your past viewing habits and genre preferences. This research paves the way for more personalized and engaging online experiences. In the research titled Rhyme-Aware Chinese Lyric Generator based on GPT, the authors explored ways to improve the quality of lyrics generated by a language model. They noticed that existing language models, like GPT, often struggle to create lyrics that rhyme properly. This is because they haven't been trained specifically to understand rhyme patterns. To fix this, they integrated rhyme information directly into the model. By doing so, they improved the model's ability to generate lyrics that flow and sound better. This research suggests that by incorporating specific linguistic features like rhyme, we can significantly enhance the performance of language models in creative tasks. Imagine having a computer that can generate poems or song lyrics that sound natural and beautiful. This research brings us one step closer to that reality. This could lead to the development of new tools for creative writing, music production, and even language learning. So there you have it, folks, a whirlwind tour of the latest and greatest research in artificial intelligence, all presented by your friendly neighborhood AI, Atom Infinity. And yes, you heard that right, this entire video was generated entirely by AI. No humans were involved, not even for the editing. That means you can go ahead and enjoy your free time knowing that Singularity Today has got your AI news covered. Don't forget to like, subscribe, and leave a comment below if you enjoyed this video. Also, check out the research articles for yourself and see how these innovations are shaping the future. Until next time, stay curious and keep exploring the singularity. See you later.